Hi guys, welcome back. So just as we have covered dimension reduction technique in the last section, now we are going to talk about data reduction technique. So I have covered clustering at a high level just to refresh your memory. In case of PCA, that is principal component analysis, we are reducing the number of columns and not the observation, that is rows. So think of a data set. Instead of using all the columns, we are going to use lesser number of columns. So essentially in principal component analysis or dimension reduction technique, we are reducing the number of variables used for analysis and not number of observation, that is rows. Number of observation will remain same. But in case of clustering, we call it data reduction technique because we are not reducing the number of variables, that is column. We are reducing the number of rows. Now technically we are not removing any rows here. We are just creating subsets of the entire data set. So if you have a big data set, you will end up breaking into smaller subsets and then using those subsets for further analysis. So just as in case of PCA, we were first doing principal component analysis and then using those principal components for logistic regression. We can do same here, but instead of using principal components, we can do that using the clusters. And as we have seen, there are different types of clustering, which I have mentioned in the clustering introduction. In this section, we are going to talk about k-means, which is by far the most popular clustering technique. And just as PCA, clustering is also unsupervised machine learning technique. And one problem with these unsupervised machine learning technique is that you cannot use them for predictive modeling. So as in case of PCA, we saw that we were reusing principal components for logistic regression, that is predictive modeling. But PCA on its own is not producing any output which is reusable as far as predictive modeling is concerned. Let's say we found our principal components. Now, if we are getting new data, we cannot use that PCA model to predict if this particular data qualifies for principal component 1 or principal component 2. This is a problem with unsupervised machine learning technique. Same thing happens in clusters. You will create cluster, but you cannot use the output. You cannot use the model for any predictive modeling. We can use the output for further analysis. And while doing that, we can use predictive modeling techniques like logistic or linear regressions on the output of cluster or PCA. And this is something which you need to remember. Supervised machine learning techniques like logistic regression, linear regression, they are used for predictive modeling. So let's say we used logistic regression for some kind of classification. Then we can put that algorithm in our production environment and we can feed new data into it and it will tell us the classification. For example, email classification. There are two types of emails, spam and ham. Ham means not spam. So once we train our model using logistic regression, we can deploy that model in production where it will operate on the incoming emails into your inbox and route them to respective folders like inbox and spam folder based on the classification. But that is not the case with PCA and clustering. For PCA and clustering, these are unsupervised machine learning techniques which are used when we are dealing with something which is called curse of data. So when we have too much of information and we don't know how to proceed with it. So we will first apply PCA or clustering depending upon the requirement. If there are too many variables, we can use PCA. If we have a huge data set, we can use clustering. Let's say we have 1,000,000 rows in that data set. There has to be some kind of segmentation there. In marketing or many other fields, you need some kind of segmentation to come up with better kind of targeting. We can't target 1,000,000 people in some generic campaign. So you would like to have some kind of segmentation there. In these kind of cases, we will first apply clustering, then we will use the output of clustering for predictive modeling. So just remember that because this is something which is very industry oriented. You may not find this information in many other courses, so don't get confused. But as far as industry practice is concerned, You need to remember that PCA and clustering usually produce output which are further used as input for predictive modeling. And in those predictive modeling techniques, usually supervised machine learning techniques are used. I just wanted to share this information with you before moving ahead with K-means because it is very important as far as industry practices are concerned. It may come up in interviews if you are planning for data science or machine learning career. So please remember it. Okay, so coming back to clustering or rather K-means. So basically it's a data reduction techniques. Case is mentioned here, so let me fix that. Sorry about that. So basically when you are working on a clustering problem, it requires higher level of domain expertise. For example, if you are working in insurance domain or banking domain, you need to have higher level of skills and information as far as your domain is concerned. You need to know what kind of segmentation is relevant in your domain. For example, let's say we are doing a survey where we are surveying 100,000 people and we are asking question about smartphones. Now, there are many operating systems, but over 90% of smartphones are either iOS, that is Apple product, or Android smartphone, Samsung and other kind of brand. If you are going to work on this data, you need to know that we have these two categories, Android and iOS, which can act as kind of groups or subsets or categories. And in that case, you can probably run clustering in this direction to divide data into these two categories. Point is, when you understand the domain, you have some kind of sense about how real business application happen in that particular domain. You can make better judgment calls because in clustering there are a lot of things where you can say that it depends upon the judgment and calls of the stakeholders or the business analysts who are working on the project. K-means is really popular for image and information clustering. So as I mentioned, basically you are working on creating these subsets. So anywhere where you are dealing with large amount of data and you need to create better targeted smaller groups. And when I say smaller, I don't mean 500 or 50,000. It's just that they are breaking the entire subset into a smaller group. The number could mean anything. It could be 5 million or 50 million. K-mean is essentially a partitioning non-hierarchical clustering techniques. So I have talked about these techniques while covering the overview of clustering. It's a partitioning clustering technique. If you don't remember all these categories, you can go back to that video. But K-mean is essentially a partitioning clustering technique. K simply means the number of cluster you want to create. As I have mentioned earlier, it requires domain expertise. Why? Because you have to choose and feed this number to your algorithm. You have to manually select how many clusters you should create using this entire data set. So don't worry, I will show you a function which is usually used to arrive on the optimum number of clusters which is used in the industry. There are few methods which can be used, but largely it's an arbitrary number. If you say 5, it could be 5. If you say 2, it could be 2. I mean, there is no specific rule deciding how many clusters should be there. So for guidance, there is a function which is used. I will show you. But if you are coming from any other course, if you have read any book on this, you might have not seen it before. Lots of courses or books don't talk about it. As far as industry is concerned, it is kind of divided. It depends upon the domain experts. So overall, to begin with, you will come up with a number, which is arbitrary number. You will say, let's go ahead with 3 clusters. You will perform your analysis. You will review the results. And then if you want, you can further go back and change the parameters. That is, change the number of clusters you would like. So it's iterative process, trial and error, and that's how you update your model to deliver optimum results. In clustering, basically our model or algorithm is going to measure distance between individual points. And the method it uses is squared distance. And as I have mentioned earlier, there are 3 types of distances or other parameters for or types of distances which can be used in clustering. Euclidean is one of the most common, but there are Chebyshev and Manhattan distances which can also be used. But the most common is Euclidean distance type. We are going to use Euclidean distance for our implementation. An objective here is to reduce the variance within each cluster, which essentially means that when our algorithm is working on creating these clusters, creating these subsets, model is going to put similar items in one cluster, one group, and dissimilar items in different groups. So items within a cluster will be closely related to each other, closely similar to each other. Whereas in comparison to items in other cluster, they will be highly dissimilar. And as I have mentioned, it's an iterative process. So you will have to also specify how many loops you want while creating these clusters. Loops simply mean iteration. So it's not like that you will start with your clustering and it will end in one shot. Your model need to attempt multiple times to figure out which particular item should go in what particular cluster. So it needs multiple attempts. So you are going to set a limit for those number of attempts, number of iterations. Let's understand this with the help of this diagram. So here we have 4 clusters. So in iteration 1, our algorithm will create 4 points on this entire plot. These points will act as a nucleus. They are called centroids. Centroids basically meaning they are the center of these clusters. And then it will allocate these points to these individual clusters. This is iteration 1. Now, after completing iteration, it will review these individual data elements. Let's say it finds that data elements in this cluster are similar to data elements in this cluster, and data elements in this cluster are similar to data elements in this one. So in the next iteration, it will move some of the data elements to this one and some of the elements from here to this one. It will also move the centroid, which is the position. So let's say this is the first iteration where we have cluster in this position. It can change in order to accommodate better similarity. So idea here is to reduce the variance. Each cluster should have points which are very similar to each other. And yes, their size can be different. So as you can see, the one cluster is bigger than other. So let's say we have 10,000 data elements in a data set, but it may only have 3 clusters. First cluster may contain over 5,000 data elements. Second cluster may have over 3,000 data elements. And the third cluster may only have 2,000 data elements. So there is nothing like all clusters are going to have equal number of data elements. Number of data elements will be different. And whenever we reach a point where our model finds that the movement of data elements, data points within groups, within clusters have stopped because all these clusters have achieved minimum level of variance. All the elements in those clusters are relevant and closely related to each other. It will stop the iteration, and this is called point of convergence. So to summarize, in k-means we are creating smaller groups out of entire data set. We need to specify how many clusters we want and how many iteration our code should run to create these clusters. Based on the input we have provided, our model will run, and in an iterative process will assign data points to individual clusters, and if needed it can change the position of centroids, that is the nucleus of clusters, and if needed it can also change the grouping, the clusters assigned to individual data elements. K in the k-mean represent the number of groups, number of clusters we want to create. The reason why k-means is so popular because computationally it is faster than many other hierarchical clustering algorithms. They are used when the number of data elements are not very high. Hierarchical or other techniques are suitable when the data size is not very big. But with bigger data sets, k-means is preferred option. K-means is also less impacted by outliers, so it is something which is data friendly. And in terms of disadvantage, arbitrary selection of the number of clusters is something which can be treated as a disadvantage. So two data scientists may end up producing two different results if they are using different number of clusters for their analysis. So this is something which will require careful consideration. I know you may still have some doubt. So in the next lecture, we are going to cover the implementation part. Probably that will help you. So that's it for now. Thank you.